Okay, so now we're going to look at the how to do some math with this equation. And one thing I want you to remind you that C, or specific heat, why is it so thick, is given in the units of joules divided by grams divided by degrees Celsius. Okay, so when you do these problems, okay, you need to make sure that your heat is in joules, okay, your mass is in grams, and that your change in temperature is in degrees Celsius. Okay. Now, the other thing that's important is that in this unit that we're in, the sign of things, the algebraic sign of things is going to be important. If you're cooling something, okay, Q is negative. If you're heating something, Q is positive. Okay, and that's going to be important. All right. So let's do these problems, and again, you're going to find them relatively straightforward. All right. So we write down our formula: Q equals MC change in T. We look for our heat. Did they give us our heat? They did not. We're solving for heat, so to calculate the heat energy needed to raise the temperature of an 850 gram substance. That's the mass. Okay. We find the specific heat, which is 0.9. Okay. And now, temperature is final minus initial. Right? So our final temperature is 94.6, and our initial temperature is 22.8, and we subtract those, and we get 71.8. And that goes in here. And this is really easy, because we're just multiplying them together. And we find that Q equals 54,927 joules. And with sig figs, so we have 3. So C49, that's 300 joules. Okay, to save time, because this is easy, to find the molar heat capacity, you just take the heat that you have here, and then you would divide by the molar mass, convert this to moles, and then take the moles and divide that into there. But to save time, we're going to come back to that actually later as well. Okay. So now, next question. We're just going to be solving for different things. Write down the equation. Q equals MC, change in T. Okay, so Q is 750. Okay. Our mass we have here is 100. They're asking for what the specific heat is. That's C. And our change in temperature, this is the final temperature. That's the initial temperature. So we're going to do final minus initial. And we're going to get 45 as I do it with the calculator. Okay, now this is algebra, right? So I mean, you guys can do this algebra. You're going to multiply this by this, right? And then I did it in my calculator, and you're going to get C equals, and you're going to divide whatever's here, divided by here, and you're going to get 0.17, and the units are joules per gram per degree Celsius. Okay. All right. The last thing that, before we get to ones that are a little bit more difficult, okay, is this problem. Okay, so again, write our formula. Q equals MC, change in T. Okay. So our heat, do they give us Q? We're looking for, there's our Q. All right. Joules of heat. How many grams? So we're solving for M. Our specific heat is 0.385. And then our change in temperature, final temperature, initial temperature. And that ends up being 55. Again, basic algebra here. Do this multiplication and divide both sides by it. And you're going to get M is equal to 56.67, I wrote down grams. In terms of sig figs, we need 3. One thing also, when subtracting temperatures, remember, you have to keep the same number of decimal places. So this has 1 decimal place, so this really should also have 1 decimal place. Still 3 sig figs. Actually, wait, no. 2 sig figs, because of this. 2 sig figs, because of that. So then, 57 grams. Not bad. Okay, I know I went really quickly through those. I mean, this is basically plugging and chugging into a formula. So which is why I went pretty quickly. Things to remember, so sig figs matter and units matter. Make sure the units match. Okay, now we're getting to the problems that are a little bit harder because you have to solve for change in temp. Okay, so it says 30 grams of ethanol at 10 degrees is heated with 14,640 joules of heat. What is the final temperature of ethanol? And then it gives you the specific heat. So let's start. So do they give us Q? They do. So I'm going to stop writing down the formula because I feel like you know the formula. So that's Q. The next in the formula is M, which is 300 grams. They give us the specific heat. Okay, now, well, they give us one temperature. Okay? You can actually you don't use that one temperature yet. Okay, we're going to solve for change in T. Okay, now if you do this algebra, and I suggest you make sure you do this algebra, remember you're going to multiply these things, and then you'll get a number next to change in T and divide. Okay, you're going to get change in T is a nice number in this case, 20. And we need 3 sig figs, so 20.0. Okay, now, what do we do? Okay, we have the change in temperature, but the question doesn't want the change in temperature. It wants the final temperature. But you know from the PowerPoint that change in temperature is the final temperature minus the initial temperature. Right? So if the change in temperature is 20, all right, and our final temperature, what did they give us? They want to know what final temperature is. And the initial temperature was 10. This is now basic algebra. We're going to add 10 to both sides. And then we're going to get final answer is 30 degrees Celsius. And then with sig figs, it still has 3, so 30.0 degrees Celsius in the end. All right. Now, the last problem, which is the one that you really need to watch, has something slightly different. Okay, so a little bit different for one reason. So it says a piece of 20 grams of copper was let cool, and had a final temperature of 21.5 degrees Celsius. Okay, if 474, of heat energy is removed to do this, determine the initial temperature, and it gives you the specific heat of copper. So, because the heat is cooled, this heat has to go into the formula as negative. Okay, we have our mass. Sorry, as I was interrupted by Tommy. Okay, so we have our mass, all right, and we have our specific heat, okay, and we're solving for temperature, so we're still going to solve for our change in temperature. This negative sign is going to be really important. Okay, so if we do our algebra here, and you remember multiply this and then divide, okay, we get our change in temperature is equal to negative 61.558444156 change in temp. Okay, this negative sign is important because now we're going to put it into the change in temp formula. So change in temperature is the final temperature minus the initial temperature. And I'm not going to write the whole thing, but I'm going to have the whole thing on my calculator. Just leave it in your calculator. So 61.5584 and whatever equals, so what did they give us in the question? Well, they gave us the final temperature. So I'm going to put that in here, so 21.3, and we're solving for the initial temp. Okay, the algebra here is tricky. Okay, so I need to scroll down a little bit. You got to watch your negative signs. Negative signs are going to mess you up here. So subtract this from both sides. And when you do that, 21.3. And when you do that math, you get 82.85, so negative 82.8584, got to watch your negatives, is equal to, now you got to watch here, because here there's still a negative I left. Okay. Now, to get rid of the negative I, you just change signs. And that is our final answer here. We need to sig fig the answer, so we need 3 sig figs. So our final answer is 82.9 degrees Celsius. Okay. Now, when doing this, it might make sense to check that your answer makes sense. So, for example, it had a final temperature of 21.5, and we're cooling it. Okay, so it makes sense that the initial temperature would be higher if we're cooling it. And sometimes it helps because the algebra here, you can lose negative signs. Okay, so sometimes it helps to look at the end of the problem and see if the answer makes sense. Okay, so for homework, you have to answer the 6 questions that are like this. I'll see you on Monday.